background. Where are you coming from? Are you coming from a data-related background, software-related background, or mathematics-related background, or any other background? Please let me know about yourself because we are only kind of joined by two of the participants, so it would be really good to know you and then kind of give you the related kind of explanation for MLOps and ML engineering. So Gina, you are from software background. Okay, so are you working as a software engineer right now? Or you have completed your studies in software engineering or computer science?
Hang on, can I just do this? It would be easier,
Yeah.
right?
Yep.
Yeah, I'm actually running a company, and we're building a product. So I'm interested from that perspective. For me, MLOps is not. I'm just trying to figure out what all these things are about, and learning as we go. So
Oh,
I'm running a company. I no longer am really working as a software engineer, only
okay, but
occasionally.
so you have like a background in software engineering, so you generally know about software components and everything. Of course,
Oh,
you.
100%. Yeah.
Yeah. Okay. Okay. So, but you don't have a. And again, do you have any experience with like machine learning? Have you kind of ever created some machine learning systems?
I know
Yes.
what it is. I've back in the day I studied artificial intelligence as well, but I
Oh, okay.
am completely out of the loop with current
Mhm.
developments.
Okay.
And sorry if I'm not on video or if I'm going on mute, it's because I'm still eating.
Okay, it's fine. It's fine. No problem. So the second participant is Natasha. Natasha, can you also please let us know about yourself? So you have engineering background, but I've been into program management for a long time. So have trained myself in machine learning, computer vision, NLP, deep learning, and interested in building AI product. Okay, that's really interesting. So because you both have a really nice background, so let's try to kind of again the slides that I'm going to present is a more generic in nature, but I'll try to kind of modify them accordingly, and I'll kind of stress more on the components that you feel like you need more explanation on. And I would encourage you to kind of have a communication with me around this topic because we are only like 3, 4 people, so I think so we can have a interactive communication instead of me presenting the whole thing. Okay. So over here, let me just get into the slideshow. So basically, at vCloud Data again, as a vCloud Data a trainer, I'm just going to present as what is it that we are offering and what is this presentation all about, right? So at vCloud Data, again, our whole kind of services revolves around data and cloud, right? Data, AI, and cloud, right? Which means that we start from data engineering, where, in data engineering, of course, you have the overall kind of engineering aspect of data. How do you collect it? Where you're collecting it from? How do you stream the data? All the processes are defined. And data engineering kind of a track covers all of that. Okay. And then usually you have BI and data analytics kind of track where it's more about analysis, basic analysis, right? Dashboards and stuff, right? And then you have a data science kind of a track, which goes a little bit further and works much more with the data. Not only just does it do the analysis, but it also do the predictive modeling and do some kind of a big data processing as well. So again, in that data science diploma program, you have also real client projects and all of that. But out of all of those, the most I would say advanced one is the AI engineer diploma program, right? And again, when I say AI engineer diploma program or AI engineering program, it actually covers almost, again, not really all of the previous things, but it kind of goes beyond the data engineering or data analytics or data science kind of a track. And the major components, I would say, is not really the deep learning aspects of AI, the computer vision, the NLP, and that stuff. But instead, it's more about the MLOps, the engineering aspect of it, the operations aspect of it, which makes it special. And I will kind of explain later on that this engineering aspect, that operations aspect, is a really powerful and important aspect, which is lacking in a lot of new machine learning engineers, I would say, or data scientists. So and there is a lot of demand for that, generally speaking, right? So let's try to understand what it is and what do we mean by that. Okay. So again, generally it's a 6-month program. Okay. So what do we cover in the whole thing? Before we do that, let me just give you a very generic kind of an overview of what generally these different programs are all about. So we provide basically trainings, and these trainings are, you can get these trainings from the massive open online courseware. You can get it from college. You can get it from very traditional boot camps as well. And usually in traditional boot camps, you also have sometimes the portfolio projects as well, and they give you some kind of a career advice as well, right? At vCloud Data, we not only give trainings and portfolio projects, we also kind of connect you with the industry mentors. It's not like a generic kind of a career advice. But apart from that, we also kind of give you exposure to real client projects, right? These projects are not like portfolio projects. Instead, they are, I mean, again, we are also a consulting company. So Beam Data is a consulting company which does the consultation, and we kind of build different products for different kind of companies. So in that process, when we have some kind of a real client project, you can also be involved with that as well. So that's something that is very different from the traditional kind of a setting. Okay. Now, again, there are part-time machine learning engineering program that we offer, and the full-time machine learning engineering program that we offer as well. The part-time is 6 months, where we are providing training for 26 different weeks, and every single week we have 10 hours of training. Okay, and in that we have portfolio project as well, but real client project is again optional. If you want to opt for it, then you can have it. Otherwise, it's totally optional. Okay. If you're going for a full-time bootcamp, then it's gonna be 3 months. And yeah, so the things that we cover usually is the review of a machine learning, and then we cover the deep learning aspects of it. Within that, we focus more on the computer vision and NLP kind of aspects. And then on top of that, which is the most important part, the MLOps, right? How to run these operations and how to kind of productionize the code that you have developed for different kind of applications, whether be it's computer vision or natural language, right? And in real client projects, you get this kind of an experience, and you also have this kind of a one-on-one career mentoring as well, right? So in this a one-on-one kind of career mentoring, which means that your resume will be reviewed and so on. So there is a lot of work that goes into it. But yeah, so that's the overall kind of a summary of what this program looks like. Okay. Again, I will get into the detail of what we do actually cover in MLOps and computer vision and NLP and so on. Okay. So the generally program timeline is that there is a pre-boot camp sessions, right, where you will prepare for the course, which means if you are lacking in some kind of skill set, you will be given opportunity to kind of and given some resources to kind of improve yourself in those domains, right? Whether it's programming, whether it's mathematics or something like that. Okay, and then after that, there is this boot camp where you will learn and practice with different labs and theory lectures, right? And then demo labs and so on. Then you will have a client project where you will build your experience, okay? And then you will have a career support where we will be kind of mentoring you one-to-one, and we'll try to help you land a job, okay? And hopefully at the very end of mentoring, you will have a job offer, okay? So that's the main timeline, okay? Now, the today's agenda is basically trying to help you understand the ML engineering and the ML ops, and then trying to kind of help you understand the best practices for the machine learning and how to do the machine learning at scale, right? And then kind of get into a little bit more detail around what the program actually covers, the a little bit of more content of the program. Okay, so for the machine learning engineering, if you look at the generally, again, by the way, data science had become famous even in 2016 and 2017. But this machine learning engineering, this job role is has is becoming more and more famous. And people started looking into it even earlier, way earlier in 2016, and you would see that there is this kind of a spike in the people and the demand for the machine learning engineers, right? And then you would see that in 2019, in about May of 2019, then there is this sudden spike for MLOps as well worldwide, right? So this requirement for the MLOps. So MLOps is becoming more and more famous, and there are a lot of job titles related to MLOps, and it's a major component to make AI system get into production and really bring some value to your business, right? So without MLOps, even if you do really good machine learning engineering and create really good kind of a machine learning model, right? And if you're not able to productionize it, if clients are not able to use it, you're not able to generate some money out of it, right? So again, your whole kind of a motivation is business at the end of the day, yeah. So it's a monetary value that you're getting out of your models, and that is only possible when you kind of have this operations kind of a skill set, right? Because at the end, that is something that will be used. You will be kind of productionizing your code on the cloud and giving the access to the clients, and they need to have a very smooth kind of experience working with these different kind of systems. Even from a recent kind of I would say example of LLMs. Even if you're creating some kind of a chatbot or something like that, you have to take into consideration so many factors when it gets or when it kind of revolves around the client, right? Because at the end of the day, the client cannot wait. They don't care about what kind of a model underlying you're using, what kind of APIs you're using. They really don't care about the sophisticated kind of machine learning system or machine learning model that you have developed, right? What they really care about is what is, how they are experiencing the system that they are having, right? What is the lag time? How quick you're able to generate the answers, right? And yeah, so all of that is related to the operations part of machine learning, right? How you're scaling up and scaling down, how you're managing all of the costs, right? And are you using the optimum tool, the right tool, which could really scale with your business, right? So all of these kind of decisions is also kind of revolving around this field of operations, right? In traditional settings, DevOps is a separate team, usually in companies, which will take care of these operations. So there is a development team, and then there is a testing team, and then there is an operations teams, and so on, right? But in the case of machine learning, roles have become a little bit more kind of intermingled, right? And you need to have, and that's why it's really difficult to find people in that kind of a particular area as well, because you need to know about not only data science, you need to know about machine learning, which means that not machine learning from a sense that, oh, you know how to create a model, but also to how to fine tune the existing models. And at the end of the day, it's all about how you come up with a solution to the problem, right? It's not about creating sophisticated models. It's all about coming up with a solution, for a particular problem. So you need to have that knowledge, but at the same time, not only coming up with a solution, but a solution that could be monetized at the end of the day, right? So you need that kind of operations as well. So it's just a well-rounded kind of a skill set, right? So that's why it's a little bit difficult to find, and yeah. So and it is becoming more and more important, because of the AI integration in a lot of businesses nowadays. Okay, so. Now, the perception is that ML productions are mostly about machine learning. Just give me a moment. Let me stop share and let me again share. Okay. So the perception is that the machine learning productions are mostly about machine learning. right? This is the perception that the machine learning code takes up a big chunk, right? And then there is a data visualization, collection. You are monitoring your model, you're analyzing, you're managing your processes, you're extracting some features for your machine learning. There is configuration for your machine learning code. There are resource management because you're serving the machine learning code, and you have to kind of manage the infrastructure as well. So it seems like, out of all of these different boxes, it looks like the perception is that the machine learning code itself, the PyTorch model, the computer vision model, the NLP model, right? The big data Spark ML model, right? Or the Hugging Face model, whatever, would take most of your effort as a machine learning engineer, right? However, that is not the correct perception, right? How, when you are using the machine learning in production, it requires a lot of engineering and operations. Okay. So in reality, this ML code is just a small kind of a piece in the whole system, right? You can see that a big chunk is about serving infrastructure, right? And then, of course, you have these feature extraction even taking more kind of a space, right? And data visualization is even taking more space. Almost everything is taking more space than ML code, right? So ML code is not that big of a part of overall machine engineer kind of a day-to-day task, right? So there are so many other things that learning engineers should be taking into account. Okay. So generally, if you look at the skill set, again, these are different skill sets, and their, you could say that their popularity across different kind of job roles, like data analytics, data science, data engineering, and machine learning engineering, right? So again, you can look at these percentages on the left, right, for all the different kind of tools, right? On the right, however, I want to focus more on that, which is all about machine learning engineering, right? So you can clearly see that, of course, Python is one of the most famous ones, right? And then TensorFlow is also a very famous one, and of course, Spark and PyTorch. So all of these first four, right, is kind of, something that usually, as a data scientist, as a traditional kind of a machine learning specialist, right, or anyone who has kind of taken some courses in academia, right, would be very much familiar with these. Python is, a very famous language. If you don't know Python, of course, you really don't know anything about machine learning. Then in that case, right, then that's like a basic, right? And then TensorFlow is, of course, a very a library for deep learning, which is mostly used for kind of, again, developed by Google, and very famous for kind of a production settings. PyTorch is also famous, but it's more for a research focused kind of it's a more research focused kind of a library. Of course, I mean, it's getting more and more popular in the industry as well. A Spark is for big data. So again, I'm assuming again that you would know about these kind of tool sets, not at a very large scale, but generally whoever is coming from some kind of a machine learning background or a data science background, they would know about these basic tool sets, right? But then you would be astonished that Java is also very famous across machine learning engineers, right? Why? Because the enterprise level kind of applications, are developed in Java programming language. So it's kind of interesting to see that as well. So you would also see C++, So it's not only about Python. Of course, Python is very famous and very desirable. But you cannot ignore the other programming languages as well. Generally speaking, it's not that you should know, but it's just that if you're applying for a company, you should know that what kind of a tech stack they are using, right? And yeah, so then Hadoop is again big data framework. Okay, and then you have a Linux, right, which is again scripting tool, which you should know, as in usually DevOps people know about Linux, so you should also know about Linux because you will be kind of doing tasks of the operations engineer, right? Then Scala is again related to big data, right? SQL is, of course, for structured query languages, the database administration and so on. So usually you will be doing it for analysis purposes and writing different kind of SQL scripts, right? Scikit-learn is for Python library for traditional machine learning, right? AWS, again, depending on what you want, AWS, Azure, or Google Cloud Platform, one of the cloud services. The cloud services is also very important, right? Then you have Kafka, and then you have R as a programming scripting language as well. I mean, again, it's a statistical language, right? Then you have Cassandra, Tableau, Git. Git is very important as well. Across machine learning engineer, because you need to know how to do the continuous integration and continuous development. So there is a more of a software engineering aspects to it as well, right? And then you have a Hive, and so on, right? So these are really kind of some of the important kind of tools that you might see whenever you are looking at some of the machine learning engineering kind of a jobs, right? So as you can see that it's not just about machine learning. It's it's much more than that. Okay. So, generally, if you look at the data science best kind of practices, right? You have some kind of objectives. Then you look for the data sources. There is a business objective. You look for the data sources to fulfill those business objectives, right? You create some kind of a theory that, okay, I will be able to solve this problem by using this kind of a data. And then you look for the data sources. Where can you collect that data and the corresponding labels? Then you do the exploration in order to find out and see if you can create some interesting features. Then you create a pipeline in order to take the data from in the raw form and create really nice features. And then you do some kind of a machine learning, and then you do the tuning of the machine learning models to get the best model. And once you have the best model, you would deploy that model, right? That's the usual best practice for data science, right? And the way you do the deployment is usually through containerization, right? You would use the Docker technology and Kubernetes and so on, right? And again, the way you do it is that it is reproducible, right? And portable, right? And of course, you will communicate the results, and project management would kind of, project management team would kind of, look into these whole aspects altogether, right? And again, the whole process is done by with a product mindset, where the main focus is at the very beginning objective, which is all about product, right? There is some kind of a product that is the objective, that okay, I need something like that because that will generate this kind of a revenue, and I'm assuming that these are the data sources that will help me. And in the process, you create this whole pipeline and kind of improve it again and again, right? So that's the usual best practice for the data science, right? Now, if you look at the data science generally life cycle, and then we will talk about the machine learning best practices as well. So if you look at the general life cycle of a data science, you have a data, you ingest some kind of a data, you have some kind of a data extraction pre-processing steps, then you do the data analysis and exploration, then you do the development, you do the model development, you train the model, you test the model and analyze the model, right? And based on that, if you found the best model, you will deploy the model, and that deployed model would be live, right? So people would start using it, right? Via some kind of an API, via, let's say, your front end application, whatever, right? So live system means you have deployed it and now people are using it, okay? Yeah. So now, if you look at the overall system, once the system is live, right, that live system would take the data from people, would give some prediction, and the data that you've collected from people will be given back to the ingestion pod, where you're collecting this data, right? In continuous manner, right? Of course, when you ingest new data, of course, you will do this whole process again. You will extract, pre-process, analyze, explore, do the development, training, testing, and analysis, right? And once you have done the testing and analysis, let's say you found out that, okay, this model is a good model, or this model has drifted, or maybe I'm not able to kind of really find a good model given this new data because the new data has been shifted in distribution or whatever, right? Then you will go back to the original raw data and try to find out if you could create some new features or something like that, right? So this kind of a process repeats, right? In all of this process, the three most important part, the model development, training, testing, and analysis, is usually something that you might be very much familiar with if you're coming from a data science and machine learning background, right? And usually people do try to kind of try a very simple baseline model, right? And again, over here, you will be using auto machine learning tool as well. PyCaret is one of those kind of a tool, right? Which allows you to very quickly kind of try out some very base models and see what is the baseline performance of these models, right? But generally, of course, you will have to you will have to conduct this extensive research on how you are creating these models and finding the best models, right? So you have a data set, you will divide it into different kind of a training and tests. You will try to kind of train multiple models, and based on that, you will find out the performance, and then you will kind of find the best one and look at the test performance, and the one which performs best on the test one, you just that would become the winning model in a way, right? So again, I mean, this is something very familiar, I think so, if you're coming from that data science kind of a background, right? So now, deploying, because again, I mean, once you have found the best model, assuming that you have already found the best model, right? So deploying just the model, is part of the workflow is not enough, right? You can't just deploy the model, because the model itself takes the data which has been transformed and extracted and pre-processed, right? So it's not just a raw data that is given to the model. There are some pipeline of transformations and pre-processings that happen in order to create the relevant features which is given to that model, right? So you need to deploy the whole pipeline, right? So usually you will transform the data, extract the feature, pre-process the features, and then train the model. That is what usually we do. So in the case of prediction, when you're deploying the model, in the live system, when somebody comes in and click on your system, you should collect the data and do the same thing. Transform it, extract the feature, pre-process it, give it to the model to get the prediction, right? So usually, you will have these pipelines, right? But that's not enough. You also have to do, I mean, again, this is all about machine learning. I'm not yet talking about the operations part of it, right? Which is kind of a big part of it, but just the machine learning part of it. And I'm not talking even about the different kind of algorithms. I mean, I'm assuming that you already know about that stuff, right? So I'm just talking about the general kind of a workflow that is there when you're kind of creating a machine learning system, and productionizing it, right? So it's not just about productionizing a machine learning model. It's also about interpreting the model, right? Why the model is giving you the predictions that it gives you. There could be some reason, right? What features are the most important ones? How it is affecting it? Maybe sometimes you're required by the law in order to make some prediction or decisions, you have to explain the decision to your customers, right? In that case, you have to also have this kind of a different interpretation algorithms, right? And you have to deploy them as well in order to kind of explain those decisions that you're making as why you're rejecting their application or accepting their application or whatever, right? So this interpretation is important for multiple reasons, not just for analyzing your model or finding out the errors in your model or kind of improving your model in the next iteration. It's also important to understand the feature set, and also kind of important from a regulation perspective as well, depending on if you're required to kind of explain the predictions or not, right? And then you have a dashboard usually, right? And you can have multiple dashboards, internal dashboard to understand if the model is behaving the way that you're expecting it to behave, right? So usually the internal dashboard would also look into the data drift and model drift, right? So if the new data is coming in, you're interested in finding out that if the new data, if the new set of people who is kind of accessing the application are different from the people that have accessed a month ago or 2 months ago, right? Because the model maybe is not updated, and you want to know if the model would perform good or not for these new customers, right? And that would only be possible if you look at the drift in them, the difference in their distributions and so on. And again, there are tools to capture that, and you can just visualize all of that drift in your dashboards. And usually, I mean, again, if you're looking at the operation side of it, you will have these kind of alert systems, right? So every 2 hours or every 3 hours, you can have an email alerting you what is happening in your production system. If the data is changing, if one of the feature is changing, if the model is behaving incorrectly, or if there is something kind of a fuzzy happening on, right? So you can look into that dashboard and find some kind of a problem or kind of opportunity to improve your model. So you would go back and improve your model and deploy it again, right? And this process should be very quick. So the deployment itself should not take much of a time. There should be continuous kind of a integration and development, right? So you should usually containerize your model. so that when you change your model or make some changes and you put it into production and push it to the GitHub, it should directly kind of go into the production directly, right? And this whole process should be automated, right? So this automation is also really kind of an important part of the whole process. Okay. And generally, again, I mean, you can just, analyze that dashboard to understand the predictions as well as the internal dashboard to understand the drift and the performance of the whole model and so on, right? So now, if you look at the deployment part, right, you can clearly see that it looks like that the machine learning code is this big thing, but technically speaking, whatever we have discussed, that's just a small part of it, which is shown on the right side, right? The actual kind of a deployment, is really big kind of a big kind of a thing, right? That you should be kind of worried about, right? And you should be kind of spending time with, right? So for example, one of the deployment best practices is that you need to have MLflow, one of the tool, right, which tracks your experiments. If you're conducting multiple experiments, how should you track it? There must be some way to track it, right? You can't just write a text file where you are storing this information that, oh, I've used this model with this number of parameters, with these particular set of parameters, and I'm getting, let's say, this kind of a performance versus that performance. And I'm using these set of features and I'm getting this performance versus that performance, right? It's not really, you will not be able to manage it, right? And you will not be able to kind of do some kind of analysis on the experiments that you have conducted, right? And every single experiment is very expensive, right? It takes a lot of computational resources, right? So usually this MLflow is a tracking server, which will allow you to track your experiments and store your models and really kind of access the models that you have stored previously and so on, right? It also allows you to do the deployment as well, but deployment can be done in so many other ways as well. Okay, so again, you have a machine learning model, right? And usually you will have to track that machine learning experimentations that you're conducting, and then you can go into the server, the tracking server, and analyze the different kind of experiments that you have conducted and make some decisions based on that as what kind of model is the best model. Okay. Now, also, you will be, tracking different experiments that you're running in different kind of environments. It's totally possible that you are using Spark ML, you're using basic scikit-learn, you're using TensorFlow or PyTorch, you're using RStudio, you are conducting experiments on Databricks, it's totally possible you're conducting experiments on SageMaker and so on, right? So it's totally possible, and you will be able to kind of access you'll be able to track the experiments conducted in these different kind of tools. And all of these different tools are kind of, I would say, has their own kind of, importance and their own place in the whole kind of a machine learning, I would say, life cycle, because the Jupyter Lab and the RStudio is used for a very traditional kind of a machine learning settings, right? So the Spark ML Lab and Databricks, because Databricks is kind of managing the Spark kind of a service for you. So that is used for big data processing, and PyTorch and TensorFlow is usually for the deep learning, right? But again, the AWS SageMaker is kind of overall solution that allows you to do the experimentation and deployment and so on as well, right? Right now, I'm not really showing you the LLM related kind of different tools as well, but there are a lot of tools which are LLM related, LLM specific as well. Okay. So again, that's one thing. You have to track your experiments, but also you also have to containerize your models, right? That is what I was talking about earlier, right? Because if you are kind of pushing your models by making small changes here and there, then you can't really kind of deploy it using that kind of a complicated kind of a script again and again yourself, right? What you really need is some kind of an automated kind of a way of containerizing your whole model and your whole process pipeline, and then creating a Docker kind of a file, and then you just push that updated code that would kind of run the whole image and pull the whole image and run the whole code that is already containerized. So you don't have to worry about all the internal details, right? So that's a good practice, and usually that is what is being done, right? So in machine learning, this is really important that you know about the Docker and the Kubernetes and this microservices kind of infrastructure, right? Because usually you would see a lot of times that you have some kind of a code, and that code will be containerized, and you will be pushing it to the container registry, which is available in AWS as well as in Docker Hub. And then you can pull it from there, and then you can run that container once you pull it, right? So you don't have to worry about the underlying operating system, the underlying GPUs and stuff, right? Because the whole thing is containerized, which means that the system and every single thing is packaged with it, right? So you really don't have to worry about the incompatibility issues and so on. Okay. And again, you can use the Kubeflow as well in order to, again, to track the experiments and so on. And again, Kubernetes is more about containerization technology. Okay. So yeah, that's it. I mean, that is how I would say that the end-to-end kind of a machine learning ops kind of architecture would work, right? So you have some kind of a business kind of a requirements, and then based on that you kind of design different kind of a feature engineering pipeline, and after that you will experiment different kind of different kind of models, and based on those experimentation you will find out the best model. And again, there will be a lot of kind of a circular kind of a movement where you are kind of improving your model again and again. So there will be some kind of an automated workflow as well, and within that you will have to monitor the performance of your model again and again, track your experiments that you're conducting, and yeah, so you will continuously improve, develop, and integrate your code that you're developing. Okay, so the CI/CD component also becomes really important over here. Okay, so usually, the MLOps pipeline, as I explained, there is a data engineering aspect, then the model engineering aspect, then there is a software engineering aspect, and then there is a DevOps aspect, right? So these are the four different aspects. Usually, if you're a data scientist, you're coming from a data science background, you would see something, more like, you will be more interested in probably model engineering aspect, or model engineering, side of things. But it's not just model engineering, it's all of them. So let me just show you. So in data engineering, you have data labeling, data preparation, data pipelines, feature store, data quality control, right? All of that comes under data engineering, right? Usually, companies would hire data engineer for that, but it doesn't mean that ML ops should not know about it, because ML ops is kind of a well-rounded kind of a person who should know about all of these things, and usually will be kind of working in all of these domains in some way, in one way or the other, right? So in model engineering, you have feature engineering, you train the model, evaluate the model, tune the model, and track the experiments that you're conducting. And of course, find the best model over there, right? And then package the model. That is also very important. Packaging, model packaging, right? How you package the model, and then register it in the model registry, right? So that is also very important. Packaging is a separate kind of a topic that you need to know, like how do you package your model, right? And then the software engineering aspect of it is to serve your model. Let's say you're creating a front-end application or something like that, right? And then there is a model testing, right? In software engineering, you have a unit testing, you have a integration testing, there is a model testing as well, okay? Within a model testing, you have a unit test and integration test, okay? And acceptance test, right? For the DevOps, right, which is a little bit of more kind of a, even more focused on operation side of it, it will look into the overall infrastructure of a machine learning, what kind of a cloud services you're using, where the data is coming from, how it is streamed in, right? And what kind of components are connected in what ways, right? So you define the overall architecture, right? So DevOps usually kind of deals with these kind of infrastructure related kind of a decisions, but ML ops engineer would kind of, deal with that, right? And you will kind of automate the whole ML pipeline, which means that if you push the model, it will automatically kind of test it and would kind of do the whole thing, would kind of productionize the whole kind of a code for you, right? So automation is a key over here. Then there is this model or data version control. Now this is a new kind of a concept. Previously, you would have seen the code version control, right? Which is basically GitHub, right? But you also need to, keep track of the data, right? If the data is drifting or not, so you have to version control them, right? And the model that you're creating should also be version controlled, right? That, okay, I mean, again, you should, if let's say there is a problem, you should revert back to the previous model, which was trained on some earlier data, which was not drifted or whatever, right? So continuous integration and continuous development is a very traditional kind of a, a area which comes under DevOps. In MLOps, of course, it will also be part of MLOps as well, right? And then finally, you will have to deploy the model and you will monitor the model continuously in the form of a dashboards and email alerts and so on, right? So usually, if you look at the tooling, right, these are all variety of different tools. I'm not really saying that all of these tools will be used, but these are all the different variety of tools that will be used, right? So for example, in data engineering, you can look at the data labeling where you can use the AWS Label Studio. You can use the Label Studio. There is this AWS, I think Manstock or some kind of a service which allows you to label your data as well, right? At a scale. And then you have a feature store. You have different kind of a feature store in cloud service like AWS as well as, elsewhere as well. Then for data query, you have Apache Spark, you have Pandas just for analysis, you have a BigQuery and so on, right? So you have for data governance and quality, you have different libraries like Great Expectations and so on. For data lakes and warehouses, you have AWS services, Snowflake, and so on, right? For model engineering, if you're tracking your experiments, you can use the library like MLflow or weights and biases, right? You can even use the AWS SageMaker as well, right? Then for registry, you can register your model in MLflow as well. There is data version control. There is a SageMaker where you can register your model as well, right? For the tuning of model, you can use the weights and biases, SIGOP, right? And HyperOpt. So all of these are used for tuning your model. For packaging your model, you can use this really famous Onyx Open Neural Network Exchange method to kind of transfer your machine learning models, right? Okay, Gina. So if you have any question, let me know. Otherwise, yeah. So I think we are also kind of done almost. I mean, we're over here. You have also trainings and evaluations that is happening. Which is done by all of these different libraries like TensorFlow, PyTorch, Keras, and Hugging Face, and so on. These are very traditional kind of libraries, right? From software engineering perspective, you have GitHub, you have, of course, Python, Visual Studio Code, and so on, right? You have code reviews and so on, right? For unit testing, for model testing, you conduct all of these different tests. For serving the model, you have a lot of different options. You have serverless options, you have server options, you have Lambda, you have Flask, you have Kubeflow, you have AWS SageMaker, you have TensorFlow Serve, you have PyTorch Serve, you have Seldom API Gateway, and so on, right? For version control, because that comes under the DevOps. So within DevOps, you can look into the data version control. There is this GitHub, and then there is this particular AWS services which allows you to do that as well. Then for the workflow automation, you can look into the Terraform and then there is Apache Airflow and so on, right? So for CI/CD pipeline, there are AWS services as well. For monitoring, you can have a Grafana dashboard and any other dashboard for that matter. For the infrastructure, usually you will look into the AWS overall, or maybe NVIDIA TensorRT, maybe Lambda, AWS Lambda. You can look into the Docker or Kubernetes and so on, right? So again, these are the different variety of tools which are being used, right? What tools you should be using? I mean, that totally depends on your situation and a lot of other factors that plays the role, right? But that's it. I mean, that's the overall. I mean, MLOps kind of a tooling and MLOps kind of a workflow that you will be interested in. Okay. So yeah, I mean, in our whole kind of a bootcamp, we usually kind of try to cover a lot of these different tools in order to go from a very basic data engineering to the final kind of a production or serving or DevOps related kind of technologies as well. Okay. So if you have any question, please let me know. Otherwise, yeah. Sandeep, do you have any question? Okay, so if there are no
Sorry,
questions,
I was on mute. No, thanks. It was a good presentation. You did mention a lot of stuff that I was not even aware of, actually. Um, just one question. I mean, like your PPT was really very useful. Is it possible for you to share that PPT with the participants?
Adam?
Oh, no, unfortunately, that's for internal use. We cannot share to the public, but most of the information you can go to our website. Let me share the link of our website. You will find a very clear explanations on this on our website. I just share in the chat, and you can explore all these courses like that's available and including the workflow. And if you have any question, you can go to the right top corner. There's talk to us. If you have any questions, you can just talk to one of our advisor to get more details. Yeah.
And there will be a link available as well, by the way, Sandeep, for this course, for this for this slide presentation that we have had. Adam, I think we have a link for that as well, right? Where they can watch this recording.
Yeah. So the recording will be available on the YouTube. Let me share the link as well.
Yeah. So
Oh,
you
that
can.
would be helpful. Yeah. I mean, like, just for me to again go through it, right? Like you covered so many things, and I understand we didn't have enough time. There was a very short period of time, but you tried to cover too many things. And
Yeah.
yeah, at least this recording will help me to go through it and understand in more detail, actually. So yeah, thank you.
Okay.
Thank you so much.
Awesome. Thanks, everyone. There are no any questions. Then have a good rest of the day.
Okay,
Thank you.
Marcus. Thank you, everyone.
Thank you.
Have a nice day. Bye bye.